Hello everyone, today we will be going over the system design course today, focusing on the concept of data convergence. Now, the convergence of document and relational databases marks an innovative period in data management where the two paradigms start to integrate features for a more efficient and versatile system. Relational databases, traditionally strict in schema and adept at relations, have started to adopt features like storing XML and JSON. So by the concept of data convergence, we are focusing on combining relational and document databases to put features together. For relational, for instance, databases combine components of document databases such as XML or JSON as an example, and it's leveraging on flexibility and performance. This allows relational systems to manage data that is not strictly structured, offering a more nuanced approach to data storage and retrieval. Document databases like Rethink database, which is a document database, have begun to include relational-like features such as join operations. I'll just use a different color. Operations. And structured schema with flexibility. Overall, they are a document database which include components of relational databases. The emerging trend reflects an underlying principle. Different applications require different data model characteristics. Different applications require different model characteristics. By combining the strengths of both relational and document models, a hybrid system can provide the best fit for an application's needs, optimizing performance and providing more complex data interactions. The advantage of such hybrid systems is that they offer developers the freedom to use the most efficient data management features from both worlds. So basically, hybrid data systems combine the best of both worlds. so, yes. Here we go. Let me just zoom out a little bit more. Oop, a little bit too far. There we go. A little bit more. There we go. So now let's go over a concept example to be able to solidify our understanding. So let's imagine we're running a multimedia content platform that stores users' profiles, video metadata, and user interactions. In the past, you might have used a relational database to manage users' data and separate document databases for the unstructured metadata of the videos. So the past, use relational databases for structured content and media, media/data, and document databases for unstructured media. Slash metadata of videos. The relational part would handle the relations, like which users liked which videos, while the document database would manage the complex nested metadata associated with each video, such as likes, subscriptions, or views in general. Relational would handle relations which user liked which video, and document show present data such as likes, dislikes, or number of shares. Just using that as an example. Now, with the convergence of database models and focusing on a hybrid system, you can use a single hybrid. With convergence, instead of multiple databases, can use a single hybrid database. Where within the system you store user profiles and their interactions in a relational manner. ensuring that the data integrity and relationships are maintained. Relational databases allow data integrity and relationships fully maintained. Simultaneously, the same system allows one to manage video metadata with the flexibility of document models. Document models provide flexibility. The setup simplifies the infrastructure and queries across different data types, making the development process much more streamlined and efficient. So let me just clean this part up. Now, to be able to solidify our concept understanding with data convergence, let's go over a practice example. So let's assess the nature of the data with focusing on an e-commerce platform. So let's imagine we are tasked with designing a database system for an e-commerce platform that needs to efficiently handle product data, customer information, and transaction records. The products have diverse attributes and require a documents database for flexibility. So the e-commerce platform requires a document database. And since we were dealing with a hybrid monetization, we also need a relational database component. So for the document database, it needs it for flexibility, makes sense. And have present data available, consistently updating. We just put down available. Well, meanwhile, the other component of the whole system that we need to consider is understanding about customer information and transaction records, which are best handled by a relational database. So relational database will be using the customer info and transaction record. And as we knew before, every data system needs a database, cache, and queue. So overall, what we need to do is that we need to design a workflow process to illustrate how one would leverage a hybrid database to handle an order process from the moment a customer places an order to the final transaction completion. So I'm just going to put this right here. Whole customer walkthrough with hybrid convergence for our data system. And so the steps and entities that we're going to be going through, we will be going through actually 10 steps throughout the entire process. So So this will be a bit long, but it will give us a thorough understanding of what it means for hybrid convergence as well. Understand more between what hybrid type of resources are there for document and relational databases to fully create our system. And so the first step that we're going to do in terms of actually designing and getting our system running is that we always need to identify key relationships. And as we know, for every data system that we have, we need a database, cache, and queue. A queue to handle actually, since we've already went through the previous video, the queue, the messaging queue, mostly relates to relational databases. And for a cache, namely, if we need flexibility in data that is already present, we would go with the document database. For present and updated information. And so we already identified the key relationships. Really, we need to understand the data needs for the organization and determine what types of data we would need to store, how it would be accessed. So just going over the questions, sometimes if there are products that are showcasing, like for instance, a preview reel, namely, we can go back at our previous example that we've already stated for the social media platform. For dealing with unstructured data, we can use a document database, but for more structured data, we would go with the relational database. So always remember, it's always dependent on the data. Relational databases go with structured data. And meanwhile, document databases always go with unstructured data. And so we would fit our data depending on the nature of the relational and document databases as well. Fit the data accordingly and know about the strengths and weaknesses for each and find the right fit. Find strengths and weaknesses for each database for efficiency. Now, the next part that we're going to use is actually figuring out the resources. We are going to choose a fitting database. Since we already know that every data system requires a database, cache, and queue. First part, and I'm just going to list out pretty good database resources that can abide by our needs for a relational and document database, ultimately to be able to go through. So what we could do, and I'm just going to be grouping them all together, a relational database, I'm just going to list these examples right here. That can include, actually I'll use a different color over here for this part, and I'm just going to go with orange. Okay, relational databases include the following. MySQL, they always focus on structured data. Post, GRE, SQL. Then SQL Server. Then what we would do is that we can do with document databases. And a lot of them merge on NoSQL. So just stating in particular, so NoSQL. That can also include MongoDB. Cassandra. Or Couchbase. Then we can, another one is called, let me just pull this up, in-memory databases. Which would include Redis or memcached. Memcached. And graph databases. Which include Neo4j or Amazon Neptune. And time series databases. Which include InfluxDB or Prometheus. And I'll put links for every single database in the description as well for further resources at the same time. But to be able to go through our example as well, the third part that we're going to need is that we're going to design our data architecture. We're going to determine how the data will be structured and stored across different database types. Determine storage across database types. And then we'll decide which data will be stored in each of the databases based on factors such as data model, scalability, performance, and query requirements. So we're going to figure out our trade-offs for each database for, just name, performance, scalability, data model, seeing if it's the right fit. I'm just going to put in fit right over here. And query requirements. Query requirements. All right. Then obviously the next step that we will be doing after our design is to focus on integrating databases. And when we integrate our databases, we're going to implement mechanisms to enable communication and data transfer efficiently between different database types. So we will implement mechanisms for data flow. And communication between database types. This would include some of the following examples. We would use ETL, which is extract, transform, and load. Which are a series of tools. ETL tools are tools which allow transfer data between different databases to be able to fit in with relational and document databases merging together. We could also implement APIs. For data transfer. And we could also utilize built-in features of certain databases, or utilize inbuilt features of present databases. We are using. And then what we need to do afterwards, we're going to do data synchronization. Where we establish a process for keeping data synchronized across different data types to ensure consistency, and implement replication. Across different databases for scalability. And updates for real time / scheduled intervals for data implementation. And retrieval. Now, the next part that we would need to do, implement security slash, or actually, and that. Implement security and failures / faults protocol. So we would set up monitoring tools to track performance and health of our data system from a hardware, software, and human side. And we would implement security features to protect data across all different data types. Or database types, I should say. Actually, data types, because we're dealing with caches and queues. So, since we'll be doing databases, caches, and queues. The next part that we have, step 7, is going to be monitor and maintain. Maintenance. Monitor and track our hybrid data system. And establish maintenance procedures for regular updates. Next, we need to test and optimize. Test the hybrid system for performance, scalability, and reliability requirements. And continually improve performance and efficiency. Step 9. Step 9. Document in training. You need to document the architecture, configuration, and maintenance of our whole hybrid data system. And we need just to provide training for all data architects for communication. On procedures for fault/failure protocols. And finally, step 10, we always focus on scalability and flexibility. Where what that means is that we need to consider future updates for growth and scalability. And regularly review and update database and data system requirements. So let me just clean this up for you folks so you get all the steps in, since we did do a lot. And so I'm just going to go through this entire part. If one needs to take screenshots, by all means, feel free to. So just going through each of the steps, because I know we did a lot. I'm also going to put the steps in a text description down below. So feel free to be able to use that as reference as well. This is just part of the lecture series of what we have for our notes. If you want to take pictures or you want to be able to follow along accordingly while writing the notes to help cement the concept, by all means, go for it. So pause the video, feel free to actually take screenshots of all the steps necessary for your own personal notes as well, just for reference as well, because I know we did a lot. So this is just giving an overview for the hybrid convergence for the e-commerce platform over what we need in terms of the process when combining both relational and document databases, and then also giving an overview of some of the resources at the same time. The links will be for all the resources in the description below, so you can check them out, namely, and get a further understanding between different databases that are used to be able to build out the database cache and queue for a whole data system for not just an e-commerce platform, but for general approaches as well. So again, feel free to pause the video to get this information down, because right over here. Yep. All right, now let's go over a second practice problem to be able to help solidify our understanding. Except for this time, we're going to be focusing on creating a database within a specific realm which requires a higher amounts of regulation. Namely, hospitals and healthcare have to abide by HIPAA regulation for the sake of data privacy in the United States. So we will be focusing on exactly creating a data system. Particularly in this practice problem, we are tasked with creating a hybrid data system, which is HIPAA compliant, and for every data system that we have, we're always going to need a database, cache, and queue. And then as a result from that, since we were dealing with a hybrid data system, emphasize that point, that means we're both going to have a relational and document database. So overall, let's imagine that we are creating a hybrid database system for a healthcare management application, and this system must efficiently handle sensitive patient records, facilitate appointment scheduling, and securely maintain medical histories. We need to create a data system which complies with HIPAA regulations to ensure protection of personal health information. So I'm just going to put this right here. Actually, a different color. Personal health information. PHI. Just going to abbreviate it for that. And we will create a plan that utilizes a hybrid database model, combining the strengths of both document-based and relational databases as well. So overall, we'll be going through a 10-step process as like before to get a further in-depth understanding of how to create a hybrid database system. And within the 10 steps, we're also going to be emphasizing our point of HIPAA regulation, where it can also abide by other domains as well, since we're focusing on domain-driven design. So let's go over these 10 steps. First step that we need to do is abide by compliance and data requirements. Typically that involves conducting a HIPAA compliance risk assessment, to identify potential PHI, personal health information, and implement measures to mitigate risk. And then that means we also need to identify types of data within personal health information that can also abide by appointment details, medical histories, and determine how they'll be stored, accessed, and protected. So overall, we need to determine how personal health information is stored, accessed, and protected. Step 2, we need to do database type selection. And as in the previous example that we did, we went over a different set of series of databases that are available for both document-based model and then relational-based model as well. So in this case, we're going to be focusing on choosing a document-based model first, data model or database, and choosing a relational database, there we go. We can choose MongoDB for the document based for flexible patient record. For both storage and retrieval, since there are other components of data that we also need to get from PHI. And a relational database that we can use is that we can use PostgreSQL. And since that can be stored and doesn't really have to be accessed, and there's only one point, and structured data, we can use appointment details. For remember, relational databases always focus on structured data, and document-based databases focus on unstructured. And then we also need to make sure that both databases abide by HIPAA regulations and they require audit controls. And they also need to have established business associate agreements. To handle personal health information. PHI, right over here. Then the third part that we need to do is develop architecture design. And with architecture design, we need to map out each type of data that will be stored, accessed, and retrieved. Assess basically all the data. All the data to be stored, accessed, and retrieved. And that means, in particular, if we're storing patient information, that means we'll have to work more with the document-based model for a little bit. But for relational databases, let me just put this over here for document. Oops. Document database. Then for the other part, for scheduling, we go with relational. And since we already have those parts already established, we would then implement indexing strategies. One second. There we go. Implement indexing strategies for both databases. That's also going to mean, since we're focusing on HIPAA regulation, that means we need to design the system to include mechanisms for automatically logging off and encryption key management. So we need to apply encryption key management. And anything with patient records always needs to be encrypted. So that's just pertaining for both, and that's just for the sake of the architecture as well. Even if we're implementing new features such as relating with the front end component to the back end of already storing our data in posteriori SQL and MongoDB as well to be able to combine for our hybrid database. And so we need to integrate for communication for the next step. So step number 4, integrate data flow and communication. So we can have secure, HIPAA abiding, I misspelled HIPAA for a second. I apologize on this. So we need to have secure HIPAA abiding API implementation if we choose. That means we're also going to have to apply audit controls. Access logs. And data integrity. We can also, and we kind of have to use this, we need to use middleware for data transformation. And ensure the exchange of personal health information is encrypted and traceable. So we use middleware for data transformation for the sake of encrypted personal health information. And then for communication channels, we need to abide by HIPAA's security rules transmission. I'm trying to use a different color. So HIPAA security rules transmission. Sorry about that. Just want to clean up and make sure we're on the right track. Apologies on that. Rules. All right. Then the next part that we need for step 5 is going to have to be data synchronization and security. So data synchronization and security. Where as a result, we need to implement real-time data synchronization. To audit trails for PHI updates. And we also need to develop robust security protocols, including, well, as stated before, encryption, access control, and frequent security audits. All right. Encryption, access control, and security audits. And obviously, so this is for implementation. For security. And so for the next part that we need to monitor and maintain for mitigating potential faults which could lead to failures. And then that means creating regular backup schedules and disaster recovery plans, abiding by HIPAA's regulations. So that means monitor for anomaly detection, for all three of hardware, software, and the human side too. And then we would then focus on testing, optimization, and scale ability, where this part performs comprehensive testing to verify HIPAA's compliance and security. There's typically a HIPAA layer that one needs to go through to review database performance and scalability. So we review database performance and scalability. For HIPAA compliance, and data transfer, abided by all layers, including HIPAA compliance. Layer, because there has to be a series of protocols that one needs to put in terms of the data flow going between the different databases that we're using, and sensitivity of the patient's health information, the different types of data that we're using for both our relational and document databases as well. The next part being for step 8, documentation, consistent documentation. It's just by principle, add comments. For updates as usual. Because, I mean, you have to abide. If you are dealing with patient's health, you have to consistently comment as a result for any changes, or patient health records are also implemented as well, since also insurance policies at the same time. The next part that we need, after we go through the entire relation, we need to do a fault tolerance and redundancy planning. Where in this, we design fault tolerance systems. Design for fault tolerance. Again, always abiding by the hardware, software, and human side as usual. And the technique that we use is going to be called RAID. So the RAID technique is redundancy array of independent disks. Redundancy array of independent disks. And we use RAID, redundancy array of independent disks, for data storage to protect against the data loss from drive failures. Used to protect against data loss and or drive failures. And then finally, for step 10, we have to develop comprehensive error logs. Handle the mechanism for any fail-safe protocol. Handle mechanism for any fail-safe protocol. And this is also abiding by HIPAA compliant error handling protocols. There we go. So let me just clean this up for you folks so that way you can all get a bigger picture of what we are facing. Just give me a moment. Okay, so I know this is a lot of information, but it's for us to be able to get a thorough understanding. Hang on. There we go. Okay, let's just zoom in. That way you folks can actually see the steps accordingly, and I'm going to move to the right. So again, feel free to pause the video, take screenshots if need be, as always. All right. Clean up more of this. There we go. All right, here we are. Again, I'm gonna move slow, and if need be, feel free to take as many screenshots as need be. So I'm gonna move from the left all the way to the right. So this is what we have. You create a hybrid data system right over here, and I go through the 10 steps. Abide by compliance with data requirements, database type selection, choose a document, choosing a document-based database where we focus on unstructured data, choosing a relational database with structured data, abiding by HIPAA regulation and patient health information. Third, we need to develop architecture design, assess all the data to be stored, accessed, and retrieved, and it's a document database. For scheduling, we will use a relational database, implementing indexing strategies for both databases, and we have to abide by a HIPAA regulation to apply encryption, key management. That's a security protocol. Step 4, we integrate data flow and communication, have secure HIPAA abiding API implementation if we choose. There might be specific ones. We apply audit controls, access controls, or access logs, and data integrity. And we use middleware for data transformation for the sake of encryption, for patient health information. Here. And for communication channels, we have to abide by HIPAA security rules for transmission. Step number 5, we do data synchronization and security, implement real-time data synchronization audit trials for patient health information updates. We have to employ encryption, access control, and security audits, which is just basic implementation for security. We monitor, maintain for mitigation of potential faults which could lead to failures. We monitor for anomaly detection in the hardware, software, and human side. Step 7, testing, optimization, and scalability. We review database performance and scalability for HIPAA compliance and data transfer, abiding by all layers, including HIPAA compliance layers. We have consistent documentation, which means we just need to add comments for updates as usual, since we are dealing with high regulation environment. Number 9, we have to implement fault tolerance and redundancy planning to design for fault tolerance in hardware, software, and human side. Typically in hospital management, there's RAID, which is redundancy array of independent disks, which is a backup protocol to be able to store patient information or any other means of information that we may need for the sake of hospital records. And for 10, we need to develop comprehensive error logs to handle handles mechanisms in a fail-safe protocol and abiding by HIPAA-compliant error handling protocols. So I'm going to zoom out, go from the left to the right again, except for more of an overhead view. And again, feel free to pause, review the entire notes right over here. There we go. Again, feel free to pause to be able to get this. And so, yeah, that was practice problem number 2. And this was implementation for hybrid databases overall, and convergent document and relational databases. Thank you very much for taking time to be able to watch this. If you found this helpful, be sure and feel free to like and subscribe. And if you have any other questions, feel free to put it in the comment section. And as always, take care. Cheers. Bye-bye.